If you want to see um, the most sophisticated cutthroat digital technology in the world, you really shouldn't look at a Silicon Valley server farm. You should honestly look at a potato.
Yeah, which sounds entirely ridiculous when you say it out loud.
Right, because normally when we think about a factory upgrading its tech,
Yeah.
the mental image is just, extremely physical.
Oh, absolutely. We picture like a rusty old conveyor belt being swapped out for this sleek, gleaming, robotic arm.
Exactly.
Yeah.
You assume the manual tasks just get faster, the profit margins get a little wider, and, the human workers transition from holding wrenches to holding tablets. It's just an image of pure mechanical automation.
And we've really been conditioned to view industrial technology purely as a substitute for muscle, like a machine lifts heavier boxes or a machine drives a truck longer distances without sleeping.
But if you step into the invisible, really high-stakes world of modern supply chain management, that robotic arm metaphor completely falls apart.
It really does. It shatters.
Because we're looking at a digital landscape that isn't just changing how fast a cardboard box moves from point A to point B. It is fundamentally changing the human brain power behind the entire operation.
Yeah, it's a huge structural shift.
So today's deep dive is exploring exactly that. We're looking at how installing high-tech digital systems doesn't just speed things up, it actually democratizes innovation. We want to figure out how technology alters who gets to come up with the best ideas and, how entire companies actually learn from each other.
Because the transition from physical automation to like cognitive collaboration is just staggering when you look at it up close.
Right.
We are moving away from a world where massive corporations dictate every single term and moving toward a highly collaborative, almost egalitarian system.
But with a very surprising, secretive twist at the end, which we will definitely get to. To explore how this actually works on the ground, we are unpacking a really detailed 2026 academic paper. It's from the International Journal of Production Economics, and it's titled, Supply Chain Learning in the Australian Food Industry, The Impact of Digital Transformation. So, okay, let's unpack this. Before we can see how technology changes the game, we really need to understand the baseline.
Right, the playing field.
Yeah, how companies in this sector historically communicate and learn. Because when the researchers talk about digital transformation, or DT, they throw around a ton of heavy terminology.
Oh, the alphabet soup is real.
Yeah. We're talking about the Internet of Things, big data, artificial intelligence, RFID tags. It can quickly sound like a tech brochure.
So let's strip away the jargon for a second. Digital transformation in this specific context isn't just about, downloading a new software update for the accounting department.
Right.
It's about bringing inert physical objects into a living digital realm.
Like what?
Well, take an RFID tag or a wireless sensor. Instead of a warehouse worker manually counting bags of flour on a clipboard, you have a pallet of ingredients that literally announces its own location. It broadcasts its exact temperature, its expiration date, right as it rolls off a delivery truck. The physical materials are constantly talking to the network in real time.
And that leads into the other big concept here, which is supply chain learning, or SCL. And the paper is very specific that this is not just some internal corporate training program.
No, not at all.
True supply chain learning has to go beyond just one company or even like a simple two-company relationship, which they call a dyad. It requires a triad.
Yeah, the triad is basically the foundational building block of this entire research.
Okay, break that down for us.
So a triad typically consists of 3 tiers. You have a supplier at the origin, a focal company in the middle, so that's like your massive food processor or manufacturer, and then a customer at the end.
Which would be like the grocery store.
Exactly, a major retailer or a grocery distributor in a commercial context.
And doing this in the Australian context makes it an absolute pressure cooker for innovation. Because, well, the food industry there is massive. It represents over 2% of the national GDP, and it accounts for more than 25% of their manufacturing jobs.
It's a cornerstone of their economy.
It is. But you also have the brutal geographical reality of Australia. I mean, you are dealing with vast, empty distances between farms and cities, immense logistical hurdles, and they rely heavily on offshore suppliers for various components.
Right, so companies are forced to become fiercely efficient, or they simply go bankrupt.
Exactly. And historically, the way learning worked in this environment, it always reminds me of a middle school group project where there's that one incredibly bossy kid.
Oh, that is a remarkably apt way to visualize the traditional power dynamic. I love that.
Right. There's always one student who holds the master document, decides what the thesis is, does all the high-level learning, and just, barks orders at everyone else to go fetch the glue or cut the construction paper.
The dictator of the group project.
Exactly. And in a traditional supply chain, that bossy kid is the focal company. It's the gigantic food processor with all the financial capital and the market dominance. They do all the strategic thinking, and they just tell the farmers what seeds to plant and tell the truck drivers what highway to take.
Right. And what's fascinating here is that the research formally categorizes that dynamic as captive learning.
Captive learning.
Yeah. It's based on a framework from Sylvester and colleagues from 2023, which details 4 distinct types of supply chain learning.
Yeah.
So you have captive, consortium, selective, and distributed.
Okay.
And the entire framework basically boils down to just 2 critical questions. First, who drives the learning? And second, who is that learning shared with?
So who drives the bus and who actually gets to look at the map?
Exactly. In your group project analogy, the focal company drives the bus. And because it's captive learning, the benefits and the knowledge are kept entirely in-house.
Right. They only share it if it helps them.
Precisely. The processor only shares information when it directly serves their own profit margins. But, the food industry is a uniquely hostile environment for this kind of top-down dictation.
Why is that?
Because of its fundamental nature. It's incredibly fragmented. The health and safety regulations are just draconian. And most importantly, the goods are biological. They are perishable.
Oh, right.
You are fighting a ticking biological clock every single second of the day.
Yeah, you can't just park a semi-truck full of raw potatoes in a lot and tell your logistics team, we'll figure out the routing problem next week. The product will literally rot into sludge.
Exactly. The biological limitations mean that a lack of coordination doesn't just cause, a minor scheduling delay. It causes catastrophic total loss of the product.
Well, yeah.
So someone historically had to force coordination to prevent that waste, which is exactly why those massive focal companies adopted that dictatorial captive role.
Right. But to see how giving everyone real-time data completely shatters that dictatorship, the researchers actually move from theory to reality. They examine 2 specific triadic case studies.
Yeah, and the first case study looks at a beverage supply chain. And this one has a 25-year history of digital integration.
25 years. Okay, so let's look at this beverage triad. Who are the actual players?
Okay, so you have a company supplying highly specific flavor compounds. You have a massive multi-site beverage processor acting as the focal company, and then a major retailer.
Okay, supplier, processor, retailer.
Right. And over 2 decades, they integrated warehouse management systems, advanced RFID tracking, and cloud computing.
That's a lot of tech.
It is. And the culmination of all this is a series of shared live digital dashboards.
So basically, a flavor scientist and a bottling plant manager are looking at the exact same screen at the exact same time.
Yes. And that shared screen fundamentally changes human behavior. Historically, the flavor supplier operated completely in the dark.
Right, waiting for the bossy kid.
Exactly. They would wait for a purchase order to arrive via fax or email. They were entirely reactive. But now the supplier can look at the cloud data and see that the beverage processor's inventory of, say, vanilla extract is dropping way faster than usual.
Because of a sudden spike in consumer demand at the retail store.
Exactly. So the supplier doesn't have to wait for an order. They initiate the learning. They reach out and say, hey, we see your vanilla inventory dipping. We've already optimized our production schedule and rerouted our delivery trucks to replenish you before you even hit a critical low.
That is wild.
Right. That's knowledge creation and problem solving driven by the supplier. They prevent a stockout before the focal company even realizes there's a threat.
See, okay, I can easily see how a flavor manufacturer, operating in a pristine, highly controlled, predictable lab environment benefits from digital dashboards.
Sure.
But here's where it gets really interesting for me. What happens when you introduce raw, unpredictable nature into this digital ecosystem? Like when you move from a clean lab to a literal field of dirt?
And that brings us to the second case study, which is the potato supply chain.
The famous potato.
The potato. So this triad involves a working potato farm, a major chip and snack processor, and a retail distributor. And instead of just tracking pallets in a clean warehouse, they deployed environmental sensors.
So these sensors are just out there.
Yeah, they monitor the ambient temperature, the humidity levels of the raw potato storage facilities, and they trace the specific quality metrics of individual harvest batches.
Oh, wow.
And interestingly, this digital push wasn't even mandated by the big processor. It was heavily championed by a regional farmers association.
Oh, so the farmers wanted it.
Yeah, they wanted to empower the growers.
I'm just imagining like high-tech sensors buried in piles of dirt and root vegetables. It's such a funny image.
It is, but the resulting data is staggering.
Yeah.
Over a 5-year period of utilizing these sensors and sharing the data, the potato processor actually reduced their number of delivery trucks on the road by 10%. But wait, they did that even while their overall production volume increased by 26%.
Wait. Let's pause and unpack the mechanics of that, because that sounds like corporate magic.
It really does.
You do not increase your factory output by over a quarter while simultaneously slashing your transportation fleet by 10% just by, like, telling your drivers to press the gas pedal harder.
No, obviously not.
How does tracking the temperature of a potato actually eliminate delivery trucks?
It comes down to eliminating scheduled guesswork. They replaced it with predictive, data-driven synchronization.
Okay, how so?
Well, historically, a processor might schedule, say, 10 trucks to pick up potatoes every Tuesday, regardless of the physical reality on the farm.
Right, because Tuesday is just truck day.
Exactly. But potatoes hold water weight, and their frying quality depends heavily on exact moisture and sugar levels. With these environmental sensors, the farm and the processor know exactly when a specific batch has reached the absolute perfect state for processing.
Oh, so they aren't shipping water.
Exactly. They are shipping optimal product. The trucks only move when the data dictates it.
That makes so much sense.
Right. Furthermore, because they are constantly tracking humidity and temperature, they catch storage degradation early. So this means the farm stops loading trucks with potatoes that are just going to be rejected at the factory gates anyway.
So no more wasted trips.
Every single truck that leaves the farm is carrying perfectly viable, optimal weight product. You eliminate half-empty trucks, you eliminate return trips for rejected loads, and suddenly you are moving 26% more usable food with 10% fewer vehicles.
Okay, I have to push back a little bit on the farmer's perspective here, though.
Sure.
Because if you're a potato farmer and your family has been growing crops in that dirt for 3 generations, having a massive corporate processor insist on putting cloud-connected trackers in your storage bins, that sounds a lot like micromanagement.
It really does.
Honestly, it sounds like surveillance. How does that create actual collaborative learning, rather than just giving the corporation a tool to punish the farmer if things go wrong?
That is a completely valid skepticism, and in a vacuum, it absolutely could be used as a surveillance tool.
Right.
But the researchers found that sharing this data actually resolves a massive vulnerability, which is known as information asymmetry.
Information asymmetry, meaning they don't know the same things.
Exactly. In a traditional supply chain, the processor holds all the economic power, but the farmer deals with the unforgiving environmental reality. And because those two realities couldn't communicate, waste was just inevitable.
The economy and the biology were literally speaking different languages.
Perfect way to put it. Let's look at a scenario without the sensors. So a massive shipment of potatoes arrives at the processing plant, and the middle of the load is beginning to rot. The processor immediately gets on the phone, yells at the farmer, demands a financial refund, and threatens to cancel the contract.
And the farmer's probably furious?
Furious and defensive. Because the potatoes looked absolutely fine when they were loaded onto the truck. There is no learning happening in that interaction.
No, just yelling.
There is only blame, financial penalty, and catastrophic food waste.
Because neither of them actually knows what went wrong in the middle of the night on the truck.
Exactly. But introduce those cloud-connected temperature and humidity sensors into the storage facilities and the transport containers. Now, the economic power and the environmental reality are translated into a single language that both parties can read on a screen.
Oh, wow.
Right. If there's a dangerous spike in humidity in a specific storage silo at like 2:00 a.m., the farmer receives an alert on their tablet, and the processor sees the exact same alert on their dashboard.
So they get on the phone not to yell about rotting food.
Exactly. They get on the phone to troubleshoot a mechanical issue with a ventilation fan. They solve the storage problem together, collaboratively, before a single potato spoils.
The sensors basically act as a neutral third party that just removes the emotion and the blame.
Yes. And the shared view of the problem really elevates the farmer. They are no longer a subordinate waiting to be scolded for a bad harvest. They are an active, real-time problem solver working right alongside the corporate engineers.
Which perfectly illustrates the researchers' first major finding. The paper's propositions 1 and 3 outline that extensive digital transformation literally democratizes knowledge creation.
Yes, it takes the power away from just the focal company.
Right, it distributes it across multiple agents.
And this is the monumental shift from captive learning to consortium learning.
Consortium.
Yeah, in this consortium model, the flavor supplier optimizing the delivery route or the potato farmer troubleshooting the ventilation fan, they are the ones driving the learning.
It's not just the big boss anymore.
Right. The decision-making stops being based on who has the biggest legal department or the most bargaining power. It becomes entirely data-driven, continuous, and predictive.
You know, think about the last time you bought a bag of potato chips or a cold soda at the grocery store. The incredible efficiency of that product, the fact that it is always on the shelf and the quality is always perfectly consistent, that isn't just coming from the genius of the brand name printed on the label.
No, it's a massive team effort.
The digital ecosystem has given a powerful voice to the agricultural worker, the warehouse manager, and the truck driver to actively improve the manufacturing process. It's like we are watching massive, archaic supply chains move from an information dictatorship to something resembling the Wikipedia model of management.
Wikipedia model, yeah.
Like everyone in the network can edit, troubleshoot, and improve the final product.
If we connect this to the bigger picture, though, it's crucial to recognize that this Wikipedia model doesn't magically materialize just because a company purchased some expensive software.
Right, you can't just buy teamwork.
Exactly. This kind of shared digital ecosystem requires an immense foundation of human trust. It requires ironclad agreements on data ownership, strict security protocols, and seamless interoperability standards.
Interoperability, meaning if the farmer's tablet can't talk to the processor's mainframe, the whole thing just falls apart.
Interoperability is the lifeblood of the consortium.
Yeah.
If the farmer fundamentally doesn't trust the processor with their sensitive crop yield data, or if the digital systems are just incompatible, the technology is rendered completely useless.
Wow.
The researchers emphasize that without proper, equitable governance, learning remains fractured and siloed. Digital tools can facilitate and accelerate trust, but they cannot invent it out of thin air.
Okay, so we have this beautifully collaborative, highly efficient consortium. The flavor scientists, the potato farmers, the corporate processors, and the retailers are all looking at these transparent shared dashboards. They are solving problems proactively, they are dramatically cutting carbon emissions by reducing truck routes, and they are virtually eliminating food waste.
It's an incredible achievement.
It sounds like a perfect blueprint for the entire global economy. Like, if a logistics coordinator figures out a genius predictive way to route trucks using big data and moisture sensors, that underlying routing logic could absolutely revolutionize, I don't know, a clothing company delivering T-shirts or a tech company shipping laptops.
You would think so.
We must be seeing this knowledge spill over into every other industry.
This raises an important question, but that logical assumption is entirely incorrect.
Wait, really?
The knowledge is not spilling over anywhere. It is deliberately contained.
Wait, if they have built this incredibly efficient engine for learning, why wouldn't they share the blueprints?
Because the researcher's second proposition confirms the food industry operates as a strictly closed network.
Closed network.
Yes. They found that despite this extensive digital transformation and the theoretical ease of sharing data across the globe, the knowledge stays trapped exclusively within the food industry. They absolutely refuse to share their logistics innovations or supply chain breakthroughs with outside sectors. They are not talking to electronics manufacturers. They are not collaborating with clothing brands.
But why? If a routing algorithm saves 10% on diesel fuel, a routing algorithm saves 10% on diesel fuel. Why be so incredibly secretive about a simple efficiency win?
You have to look at the structural reality and the specific culture of the food sector. The complexity and the sheer scale of the safety regulations are staggering.
Okay, true.
Let's compare them. If a major clothing company messes up their supply chain logistics, a shipment of T-shirts arrives a week late, and maybe they have to offer a discount code to apologize to their customers.
Right, a slight inconvenience.
But if a major food company messes up their supply chain logistics, thousands of people get severely ill. Federal regulators shut down their facilities, and the brand is permanently destroyed overnight.
Oh, Yeah, the stakes are quite literally life and death.
Yeah.
You can't issue a discount code for salmonella.
Exactly. Because the stakes are existential, the culture is deeply inherently risk averse. In highly regulated sectors like food, and actually you see this exact same behavior in pharmaceuticals, legitimacy, regulatory compliance, and profit margins are viewed as incredibly fragile.
So they just lock the doors.
Yeah, sharing knowledge, even basic logistical frameworks outside of their specific trusted club, is viewed as an unnecessary vulnerability. It's an existential threat.
Wow.
So they benchmark their success entirely inside their own industry. A beverage company looks at what a dairy company is doing. They do not look at what a smartphone manufacturer is doing because the structural barriers and the regulatory environment of electronics are fundamentally irrelevant to them.
It's as if they're saying, look, your pallet of smartphones doesn't have a biological shelf life of 4 days, and it can't cause a nationwide health crisis, so your logistical data is completely useless to me.
Exactly. The research has concluded that these inherent structural and cultural barriers simply override the open sharing potential of the digital tools.
That is so fascinating.
The technology absolutely possesses the capability to allow for what the framework calls distributed learning. That would be a state where knowledge flows freely and openly across an expansive network of entirely different industries.
The dream of the internet, basically.
Right, but human nature, corporate preservation, and regulatory terrors keep the walls firmly in place.
So they utilize this brilliant technology to build a highly collaborative, thriving community inside the walls of their industry. But they also used it to reinforce the walls themselves.
Precisely. The digitalization successfully moved them from a captive dictatorship to a collaborative consortium, but it couldn't push them all the way to a distributed utopia. The network remains permanently closed.
Well, let's pull back and recap what we have covered today, because we have charted a major evolution in how the world operates.
We really have.
We started by looking at how digital transformation in the Australian food industry is doing so much more than just automating physical labor. By integrating the Internet of Things, real-time environmental sensors, and shared cloud dashboards, these supply chains are fundamentally changing who holds the power to innovate.
Exactly.
They've transitioned from captive learning, where the giant processor just barks orders and hoards information, to a highly collaborative consortium network.
It is a profound democratization of supply chain intelligence. Farmers, suppliers, and distributors are using shared data to proactively solve mechanical and biological problems before they result in waste.
But, as we just explored, it remains a fiercely exclusive club. They operate as a consortium, but they are a closed network, guarding their logistical breakthroughs from outside industries due to the high-stakes, highly regulated nature of food production. And I think the big takeaway for you listening is that true efficiency and innovation do not just spontaneously generate when a company buys the newest enterprise software. They happen when everyone in the physical chain has access to the data and, crucially, the cultural permission to speak up and act on it.
That's the key.
You have to empower the person growing the potato with the exact same data the CEO has in the boardroom.
The technology is merely the bridge. The willingness to walk across that bridge, share the data, and collaborate as equals is what actually creates the learning.
It leaves us with a fascinating paradox to chew on. We continually expect technology to be this ultimate boundary breaker, a tool that inherently tears down walls and connects disparate groups. But it's incredibly complex. Vital industries like food and pharmaceuticals are utilizing these brilliant digital tools to build smarter, higher walls around their knowledge. What happens when we face a complex global crisis that absolutely requires all sectors of the economy to learn from each other? Can we ever truly reach a distributed learning network where industries openly share their best ideas for the greater good? Or is human nature simply too fiercely competitive and risk-averse to ever let that happen? Something to mull over the next time you pick up a perfectly crisp bag of potato chips.